So if in a graphing calculator you type in y equals 1 over x and then graph it, you will see something that looks like this. There are some unique things about this graph. First of all, you might notice that there's two pieces to the graph. There's a lower left piece and an upper right piece. If you look at a diagonal line like this graph is symmetrical over a diagonal line. This graph is called a hyperbola. It looks like hyperbola, but just like parabola is not parabola, it is called a hyperbola, not a hyperbola, hyperbola. A hyperbola has two asymptotes. There's a horizontal asymptote at y equals 0, and there's a vertical asymptote at x equals 0. Now, if we move this graph around a little bit, just like all of the other functions that we've looked at, if we add or subtract something with the x, that is going to be side-to-side movement. That will move that vertical asymptote side to side. If we add something after that function, it's going to move the graph up or down, and that's going to move the horizontal asymptote up or down. So instead of doing a full exploration, the teacher who made this notes packet did a screenshot of this particular function. So she graphed y equals 2 over the quantity x minus 3 plus 4. Here's the picture of that graph. We need to find the vertical asymptote, the horizontal asymptote, the domain, and the range. And I think once we do that, we're going to start seeing some connections between the asymptotes and the equation. So to find the vertical asymptote, you're basically looking for the vertical line where the left part of the graph gets really, really close to but doesn't cross, and the right part of the graph comes up really close to but doesn't touch and doesn't cross. So dash in where that vertical asymptote is, and it looks like it is at x equals 3. Remember Hoy and Vux. So a vertical asymptote is going to have an equation x equals. So here's that vertical asymptote, and it has the equation x equals 3. The horizontal asymptote. Look on this picture at where this graph kind of splits horizontally. That would be the equation y equals 4. The domain and range for hyperbolas are really, really easy because they're directly tied to the asymptotes. So the domain, you can use any value of x except 1. X cannot equal 3. So write x, an equal sign with a slash through it, and then 3. That means x cannot equal 3. If your asymptote is at x equals 3, the graph can't touch or cross that asymptote. So we cannot use an x value of 3 because that's exactly where the asymptote is. Similarly with the range, because we cannot have a y value of 4, the asymptote is at 4, the range is all real numbers except y cannot equal 4. Now with the domain, I want you to see why this vertical asymptote exists. If we were to plug x equals 3 into this equation, take a look at what would happen. If you put 3 in place of that x, what is 3 minus 3? Can you divide by 0? No. That's why that vertical asymptote exists, because if we plugged that x value in, we would get a situation where we had to divide by 0, and we can't do that. Okay. Now I want you to look at the values 3 and 4 and look back at this original equation, and I want you to see if you can figure out how you could maybe pick out the vertical and horizontal asymptote without graphing this. So notice it says x minus 3 in the denominator. Where this equals 0 is going to be the vertical asymptote. 3 minus 3 is 0, So 3 is the vertical asymptote. So that's how you find the vertical asymptote. Now the horizontal asymptote 4. Do you see 4 anywhere in that equation? Plus 4. That plus 4 moved the graph up 4. That is your horizontal asymptote. So I'd like you to try number 2 on your own. This time, don't focus on the picture. I want you to focus on the equation. See if you can identify the vertical and horizontal asymptote from the equation and use the picture to check yourself. If we focus on the equation for number 2, where the denominator would equal 0 is going to be your vertical asymptote. So what number plus 3 is 0? Negative 3. Our vertical asymptote is going to be at negative 3. Negative 3 is the x value that would make the denominator equal 0. And if you check on your graph, if we try to put in a line at x equals negative 3, yep, that is the asymptote. If the vertical asymptote is x equals negative 3, that means the domain is real numbers except x cannot equal negative 3. The horizontal asymptote is the number added or subtracted after the fraction. So the horizontal asymptote should be at y equals negative 1. And if we look at the graph, yep, that does indeed work. Oops, I'm not very accurate, but that's okay. It's a little curvy. You know, you guys can deal with it. There we go. And if the horizontal asymptote is y equals negative 1, then your range is real numbers except y cannot equal negative 1. What have we learned from this? We've learned that if you have this equation, y equals a over x minus h plus k, that the vertical asymptote can be found by looking at the denominator. So the vertical asymptote is h. And I'm going to include in here when denominator equals 0. So set the denominator equal to 0 and solve it. That will give you your vertical asymptote. Whatever x value makes that denominator equal 0, that's going to be your vertical asymptote. Your horizontal asymptote is the number added or subtracted after. So your horizontal asymptote is simply k. All right, let's use this information to actually graph one of these all by ourselves using the graphing calculator very little. I'll show you how to use the graphing calculator to help you without having it do everything for you. First thing that you need to do from this equation is identify the vertical and the horizontal asymptote. So what is the vertical asymptote? Negative 2, because an x value of negative 2 would make that denominator, negative 2 plus 2, that would be 0. You can't have 0 in the denominator. That means the domain is real numbers except x cannot equal negative 2. And on your graph, go ahead and put in a dashed line at x equals negative 2. Now we're ready for the horizontal asymptote. The horizontal asymptote is negative 4. Which means your range is real numbers except y cannot equal negative 4. I know there's not a ton of space to write that in right there. Sorry about that. And make a dashed line on your graph at y equals negative 4. Choose two x values on the left side of the vertical asymptote and two x values on the right side of the vertical asymptote. You want to see what's the graph going to look like on both sides of that vertical line. So our vertical line is at negative 2. The next two x values would be negative 3 and negative 4. If you are OCD, just ignore it. It's okay if your table of values is not in numerical order. It is totally fine. It's going to be easier for you if they are not in numerical order. On the right side of the vertical line would be the x values of 1 and 0. The important thing when you're figuring out your y values, you must put parentheses around the denominator. So if you're plugging this into your calculator, you need to do 1 divided by parentheses, -3 plus 2, close your parentheses, minus 4. If you forget the parentheses, your calculator will do 1 divided by -3, calculate that, then it will add 2, then it will subtract 4. And that's not what we want. We need that plus 2 to be in the denominator, so make sure your denominator has parentheses around it. When we plug that into our calculator, we get -5. Why did I have that in there before? Weird. Okay, now you can plug each one of these values in. You can do 1 divided by -4 plus 2 in parentheses minus 4, or you can make your graphing calculator do the work for you. If you go into the y equals button and punch this equation in, 1 over parentheses x plus 2, close your parentheses, minus 4. You can then go to the table and look up all of these values in your table. So -4 is -4.5. Oh, this is supposed to be -1, isn't it? Yes, that's supposed to be -1. -1 is -3, and 0 is -3.5. Okay, so our x values are -3 and -4. That's the two x's on the left side of that vertical line. And -1 and 0, that's the two x values on the right side. I had 1 in there originally. It was supposed to be -1, I promise. Plot these 4 points and see what it looks like. Once you actually plot these points, the shape of the graph can be a little bit deceiving, but you'll notice this does look symmetrical. Did I get my points in the right spot? -3, -5. -3, -5, -4. Okay, so this isn't a lot of information, but based on what you know about hyperbolas, these are both going to curve toward the asymptotes. So if you want to look at this on the graphing calculator, you can, but these will curve toward the asymptotes. They're not supposed to like touch or cross the asymptotes, but I know with the thickness of pens and pencils, it can be kind of difficult. So curve these toward each of those asymptotes, staying within the quadrant that you see.